left channel, right channel, center.
VTuber 一問一答自己紹介
Yeah, and the tape's
それじゃあ
rolling.
行くよせーのお名前は
Katt Phloxworthy.
呼び方は
Just Cat is fine.
あなたは何系 VTuber?
Nerdy cat girl who features space
誕
flight.
生日は
May 4th.
年齢は
Older than Pneumatic.
性別は
Transgender
身
female.
長は
4'11".
出身は
Sacramento County.
チャームポイントは
Zylog hair clip.
突然ですがモノマネどうぞ
Yeah, what's up, Dad?
活動場所は
Twitch, Twitter, YouTube.
はじめの挨拶
Thank you for joining me.
終わりの挨拶
Bye.
推しマークは
Not at present.
配信タグは
Catlight
ファ
feed.
ンアートは
Cat pics.
ファンネームは
Cat's apprentices.
好きな色は
Iris indigo.
好きなことは
Vintage computers and
得
video.
意なことは
Technology.
ここで一言愛の告白好
I love you.
きな食べ物は
Ethnic foods.
好きな飲み物は
Craft soda.
好きな漫画は
Pizza 10.
好きなアニメは
Planet.
好きなゲームは
Left 4 Dead 2.
好きな音楽は
Classic rock.
苦手なことは
Human stupidity.
尊敬するのは
Space fairy people.
叶えたい夢は
ISS crew
最後にみんな
interview.
に一言どう
Thanks
ぞ
so much for your support and a final status check.
Go Atlas.
Go Centaur.
Go Katt Phlox.
You have permission to launch.
3, 2, 1. RD-180 ignition. Booster ignition and liftoff of Atlas V and Centaur. Hello, everybody, and thank you so much for joining me. Hi, everybody. Katt Phloxworthy here. This time on my YouTube channel. Ordinarily, I'd be doing this streaming on my Twitch channel, but I figured let's give this a try on YouTube and see how well it works. One of my friends suggested some time ago, in fact, several years ago, in fact, that I try doing some of my spaceflight streams here on my YouTube channel. I don't know. Ideally, I'd like to actually simulcast them if I could, but I don't know. Twitch is getting a little bit antsy when it comes to their policies nowadays for various reasons that I can't quite understand, but whatever. In any event, first of all, thank you so much for joining me, and I hope you're having a great time of day wherever you are. About to wait. Right now, we're waiting on Rocket Lab to get their feed going. They should be starting, I'd say, within the next few minutes. Although, let me go. As I always say, launch times, slippage, and scrubs are always in effect. I didn't know you were on YouTube. Yeah. It's I've always had a YouTube channel. It's just that I don't stream here very often. That's the thing. But I'm doing that right now. So it's so yeah. And one thing you got to bear in mind, also, one of the things I've noticed is that depending on certain parameters, the delay between you seeing it and you hearing me coming back with seeing your comment is a little bit longer. I don't know what it is, but it's like a 12-second delay between packets leaving my network heading out to the internet to actually seeing it on YouTube on my side coming back the other way. And but in any event, that's what's going on here. But yeah, I've been on YouTube pretty much since the beginning. The only difference is that I've mainly been just doing it on the I've been doing all my streaming on Twitch and a lot of static video on here on YouTube. Plus, on top of that, I need to get into the whole shorts thing. I know a lot of people have fun with shorts. Thing is, I suck at anything creative. Hell, I mean, look at my overlays. I actually did them all myself. I based it on Silicon Graphics stuff, but not entirely accurately. I did it this way because I like the way it looks. I wanted it to be nice and clear, concise, yet something somewhat in keeping with the old Silicon Graphics Iris desktop. But yeah, I stream every now and again on YouTube. In fact, when I used to do New Shepard launches, I would do them here on YouTube as opposed to on Twitch. Ideally, I'd prefer to do my spaceflight and technology streams on both networks, but I don't know. I don't know if Twitch is either tightening their rules or they're just they're saying that they're tightening the rules and then just saying we don't want you to do this. I mean, they originally said we don't want you to do this, but I don't know if they're actually going to enforce it. I don't know how hard it is for them to enforce it, but in any event, ideally that's what I'd like to do. But logistically on the I've got the infrastructure to do it on the network side. It's the overlays that's going to be the trick, because I kind of wanted to look just like the way Stream Elements does, but the problem is I'd like to have both chats in line with each other as opposed to two separate tail-Fs on chat logs, as it were. Because the chat that you're seeing basically is a terminal window that you see on a Silicon Graphics bootstrap system, bootstrap window, but the actual programming is actually in a proper 4DWM window that you would see on an IRIX machine. In this case, I happen to have I've had and of course the sound that you heard at the very beginning of my logo video is the sound of a Silicon Graphics Indie workstation starting up, and I've had contact with two of them in my internet service provider career, and I now own one, and I've owned one of them, and I own one of them still, actually. Anyway, I'm still keeping an eye on what's going on here because things have not switched over just yet. So let me go. Oop, that's not the right. That's not the right X one. I know it's here somewhere. Oh, there it is, right there. Do a hard reset, reload here. Everything is still on time, and they're saying they're still go for launch for Electron to launch from Launch Complex 1, Pad B. There are two. They originally only had one pad, but now they have two over at the Mahia Peninsula station where they have their launch facility. Let's go take a look, see what's going on. Not much happening just yet, but usually they might do it just be like within when they hit about T-minus 10 minutes. So we are coming up on 10 minutes away, and usually they do final go no go poll at about T-minus 11 T-minus either 12 or 11 minutes, and we're about possibly 3 minutes out from at least three, as much as 4 minutes away from the go no go poll. Basically making sure all systems and the range as well as the payload are go for launch, as well as all personnel. Because that's one of the things they do on many of these launches, is they do a final go no go poll. You'll see that all the time, a very detailed go no go poll on United Launch Alliance's streams. They'll make sure that everything in each of the stages is go, especially the Atlas Centaur and in the future Vulcan Centaur, where they make sure that all the fuel and oxidizers are ready. There we go. Let's go ahead and head over to the program. I need to go turn the volume up here. And there's the rocket. It uses a setup much like Falcon 9. It uses 9 engines at the base, then the Rutherford engine, which is much like Falcon 9 in that it uses the same bipropellant of RP1, which is a highly refined form of kerosene, and liquid oxygen for the oxidizer. And the upper stage uses, in this case, there you go, there's the vacuum optimized version of the Rutherford, and it too uses RP1 and liquid oxygen. The main difference is that it's electric pump fed.
Good evening and welcome to Rocket Lab's 41st Electron launch, a mission for Capella Space called We Will Never Desert You. You are looking at a live view of our Electron rocket.
And the white stuff that you see on there is ice, because they do not use insulation on their tanks, and that's where all the liquid oxygen is. RP1, like I said, is highly refined kerosene. It's a liquid at room temperature.
And alongside Prachi, we'll be taking you through the final minutes of today's operations to launch our Electron launch vehicle from Pad B at Rocket Lab Launch Complex 1 in Mahia, New Zealand. We've had a clear run through operations so far. The weather is looking green though, and we are keeping an eye on solar activity, also known as space weather, as we
space weather can sometimes have can play a factor in there, mainly because they can send EMPs or electromagnetic pulses, much like a nuclear blast would, and that could affect the avionics on the vehicle.
Electron launch overall, our 9th for the year, and our 2nd in a row for Capella Space, a provider of commercial synthetic aperture radar imagery, also known as SAR. SAR is a form of radar used to create 2-dimensional images or 3-dimensional reconstructions of objects such as landscapes. Electron's payload today is a single Acadia satellite for Capella's constellation that is set to join another Acadia satellite we carried to space just a couple of weeks ago for our We Love the Nightlife mission.
Today's back-to-back mission is in fact our 3rd for Capella this year and 4th overall since we first launched for them back in 2020. Let's take a look back over our missions for Capella to date.
And what they'll usually do is they'll usually launch either 1 or 2 satellites in order to build up a constellation over the course of a period of time. I can't believe it's not optical. That was one launch. In fact, there were 2 different launches. There's staging and then ignition of the upper stage as it just pulls away. I can't believe it's not optical. Actually had two. I'm not sure if it had 1 or 2 launches, but one of them actually failed. I can't remember whether it was the battery one or the fact that they when the hot swap failed right at about 3/4 of the way up the hill, as it were. There it goes. Oh wow, that's a pretty cool view from the base of the Strongback. And like Falcon 9, apparently they integrate in the horizontal position and, of course, rotate vertical. We love the nightlife. There we go, staging again. I swear, watching it stage and like the vacuum optimized Rutherford engine, to watch that thing just peel out and pull away never gets old.
Minus 12 minutes to lift off there. Oh, actually coming out on 10. Our operators will run through the go no-go poll by this mission's launch director, and this is coming up shortly. Let's listen into mission control now and check.
Let's listen and see what they've got to say.
Seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
That was mission control reporting that Electron systems and the Capella payload on board are confirmed healthy and good to go for an on-time launch. The range is ready to support and the weather is looking good for launch today. We are still targeting liftoff at 6:30 p.m. local time or 6:30 a.m. UTC.
Today's mission profile includes all of the usual launch milestones you've come to expect from Electron. 2 seconds before liftoff, Electron will light its 9 Rutherford engines on the
just
first
inside of
stage
10
to power up
minutes.
the flight. The launch pad's hold-down mechanisms will release, and Electron will head skyward right on T0. Rising up and then heading southeast from LC1, Electron will reach supersonic speeds in under a minute. That's a call-out we expect to hear from Mission Control at 55 seconds into flight. Just as we approach the mission's next milestone, Max Q, or maximum aerodynamic pressure. Once we've cleared that gate, it would be another minute and 20 seconds or so of the Rutherfords firing hot before their scheduled shutdown at MECO or main engine cutoff.
Once they do, it's only 3 seconds later that the first stage will separate from the second stage. With the main engines off and the stage 1 propellant tanks empty, Electron stages will separate to drop the dead weight. After a few seconds.
Speaking of dead weight, that actually will be retrieved. They're going to make an attempt to retrieve it by having that parachute into the ocean.
Rutherford engine to carry on with the mission. After about 30 seconds, the payload fairing will split in half and drop away. At this point in the mission, the second stage will cruise along for a couple of minutes before we reach the next milestone, the battery hot swap. We'll explain more about that step when we get there. After a few more minutes, Electron's second stage will have carried the Capella payload to its apogee, or the highest point in its orbit above Earth. We time the shutdown of the second stage engine just as we get to that marker at about 9 minutes and 13 seconds into flight. We then separate the second stage from Electron's kick stage, which carries the payload, starting to travel the Earth in an elliptical orbit.
Because we want to deploy the satellites into a circular orbit, we wait until the kick stage completes one pass and comes back around before we light up its Curie engine to place the kick stage and payload onto its circular path. Once there, it's time for payload deployment and the end of the mission for Electron and Rocket Lab and the start of operations on orbit for Capella.
Every launch is the combined effort of our dedicated teams across the United States, Canada, and New Zealand. But many of our team members behind Electron, our new rocket Neutron, and our satellites and space systems didn't come from traditional space backgrounds. They are composite boat builders, automotive mechanics, electricians.
And note about Neutron, that is going to be their new launch vehicle, which like Vulcan, as well as Starship and New Glenn are all going to be using liquid methane or LCH4 for fuel and liquid oxygen for the oxidizer.
And why it might not be as much rocket science as you thought.
As it was sitting on the pad, just messaging on the phone, like, is it gonna go? Is it gonna go? My heart was pounding, and then it took off, and that was probably the most.
And there it goes. You can see.
It was a really cool moment.
Just there, and then of course there are the umbilicals connecting there, so they can put propellants, electricity, as well as any. Actually, those don't do air conditioning like the Falcon 9 can do if need be.
I'd love to be in the space industry. I thought I'd give it a shot. The worst that happens is to say no, and here I am.
I was in school. I never considered working in a rocket company, building rockets.
I mean, working for a rocket company is kind of a big
And one
deal.
thing to note
However,
about these
like I said,
vehicles,
I
they
came
are
from
built
school
from carbon fiber
and
composites,
I was able
as
to go
opposed to
on the job
something
as an
like
apprentice. It was always that
aluminum
option.
or steel.
But
Although
however, none of us were building
in the
rockets
case
before,
of
so no one around me
Super
really.
Heavy
So
and
learning and growing
Starship,
together as
those
a
are
team.
actually made
Pretty
of
much
stainless
it.
steel because
Be like that.
apparently cryogenic fuels actually do the storage of cryogenic fuels in there actually alter the strength of the steel.
It takes people minutes to realize what we do. So yeah, it's funny just seeing the cogs tick and then realize, yeah, we're not just making something up basically.
So I would say a drive for continuous self-improvement is a big one. You know, we're always trying to improve the product and improve time and quality and everything like that.
I came into Rocket Lab not having...
That gives you an idea of how small the diameter is. It's only like a couple meters across, like 2 or 3 meters across, or about 6 to 8 feet across. It's not a very big. It's 4 to 8. It's not all that big. It stands about 60 feet tall, or about, I don't know, about 18 or 19 meters tall. And each Rutherford engine, especially the sea level one, if you look at the bottom of that, there's actually a pic. If you go to Everyday Astronaut and go and look at any of the Electron missions, you'll see CEO Peter Beck holding on to a sea level Rutherford engine, and it looks like we're holding it T-minus 7 minutes and 45 seconds. Didn't notice that until just now, so more information is probably going to be forthcoming once this video is over.
And it's crazy that we have people.
But anyway, like I was saying, each of those engines is about the size, and I don't mean this insultingly at all. It's just this. It's about the size of a tall kitchen garbage can. It really is that small. And there's 9 of them at the base of. See what we got.
Of our new large launch vehicle Neutron and expansion across our space systems and satellite manufacturing sites, our team is growing. If you'd like to be a part of it, check out the open positions on the career section of our website.
We are now at a critical juncture in the lead up to launch, the switch to the countdown auto sequence. The team are tracking no issues with the launch vehicle, Capella's payload remains healthy, and the weather is looking clear for an on-time liftoff. At T-minus 2 minutes, the flight computer on Electron will take over the launch countdown. At T-minus 1 minute 30 seconds, we should hear the call from mission control that LOX loading is complete on Electron. Shortly after that, at T-minus 1 minute, we can expect confirmation that the launch vehicle's first and second stages are pressurized for liftoff. This will be followed by the final countdown to launch at T-minus 10 seconds. Let's hand you over now to mission control.
See what's going on there. So we should be about 3 minutes out. They say they're not tracking any issues, but their countdown clock has been stopped at T-minus 5 minutes. I mean, 7 minutes, 45 seconds, sorry.
And we've just had an update from Mission Control. It looks like we've had a hold, which could be that pesky space weather. So we'll wait here to hear an update from Mission Control on whether we'll proceed with today's attempt.
Okay, so they did get that update. So basically what's going on is that the sun itself can actually be a source of issues, notably, like I've said, a source of electromagnetic pulses in the form of sunspots or CMEs, or coronal mass ejections, which can interfere with how spacecraft will work. In fact, I think a CME caused multiple. I think it caused multiple Starlink satellites from one launch to go dead because of the strong electromagnetic pulse that hit them. So in the meantime, we're going to see what's happening over the next few minutes, assuming it even goes on. As always, I like to tell everybody whenever I do these launch streams, there is always a possibility that things could end up being postponed. either within the launch window, which appears to be one here, possibly, or they may have to postpone the launch entirely to another day. So we'll see how much time. I think I can actually find out what the launch window is here. I'm looking at the wrong one here. There we go. That's not it. Let's see, actually, I don't say the exact windows where I'm looking, but typically, but not always, some of these uncrewed vehicles where they don't have a lot of these vehicles where there is no precise point in space where they absolutely have to be, like for example to rendezvous with the International Space Station, they usually will pretty much launch at will within about a 2-hour window. But in this case, they may not necessarily be doing it. They may not necessarily have that. They may have a bit more freedom than that. And apparently, they possibly will. They appear to have that freedom where they can actually. They don't have an instantaneous launch window like, say, anything headed to the ISS does. Basically, it's all up in the air. Up in the air until the rocket is up in the air. Yep, that's about a good way of putting it. How are you doing this evening? Or yeah, it's evening still here in California. In fact, this would have been the T0 time right about now. But apparently there may be some, like they were saying, they've been keeping an eye on the space weather. Notably, any solar emissions that could potentially cause an issue with launch. Not just meteorological conditions here on the planet, but stuff out on the sun, which takes about anywhere between 8 minutes to however long it takes to get out here. So anyway, well, it's not raining here. It's not raining here in Sacramento. And also, it might be worth pointing out that this is the... Oh, hey! Good to see you here. Thanks for the clarification. Yeah, this is my first YouTube stream in a normal way in a very, very long time. The last few have been tests, mainly to prove operation of various bits of the network. And by the way, how is everything sounding and looking? Because I had to go and update I had to go back to an older version of one of the plugins I use for OBS Studio. It seems to be working. It seems to be working better because the previous one had some issues. I'm also gonna go check. I'm gonna check the Electron. Rocket Lab's poll for solar activity levels scheduled at schedule T0 updates to come.
Welcome back.
Okay.
If you're just joining us today, we are in a hold as we wait for operators to establish a new T0 for today's launch for Capella. Happily, LC1 has given us quite the sunset to admire as we wait to go to space. Stay with us and enjoy these views, and we'll be back with you with an update very soon.
In any event, yeah, thanks for that update, because I needed to know about that, because I kind of needed to get a few things updated on this side. I had to I had updated some of the plugins that basically handle moving video and audio traffic, the core audio and video traffic between computers, and there were some issues going on with that, and because the previous one, when I was using the latest one, only the left channel would go through, and it was producing rather not so nice sounds on the right channel. So I had to flip back to NDI, which main thing I don't like about it is it doesn't allow me to select which interface it goes out on the various machines, or where to take input from for a particular source. But yeah, thanks for that. Thanks for letting me know about that, because I try to keep the quality as good as I can, especially considering I was watching they just recycled the clock to 12 minutes. Just waiting on a new T0, and I think at when they do that, they're gonna start counting back down from T minus 12 minutes. In the meantime, it looks like they're still they may still be topping off the supply of liquid oxygen in the tanks, all the way up until within the last couple of minutes, at which point they will secure the LO2 and the RP1 lines to both stages, and immediately ahead of launch. Yeah, and I have to make some adjustments to my overlays as well, because one of the things I try to do during my titles is make sure that people can see the text, and or at least know where it's going to end up being. So let us take a look. I'm going to go keep an eye on what's going on their Twitter. And I can also keep an eye on the actual stream itself from here. But yeah. Oh, geez, that's another thing I need to do, is also make sure all my triggers that I normally have on my custom, as many of my custom commands as I have on my Twitch instance of Stream Elements are present here on my YouTube presence thereof. Where the heck? Put that. Okay, there it is. Let's see if there's anything new. So in the meantime, we are waiting on solar weather updates, because apparently, I don't know if there has ever been an instance where solar weather has actually interfered with a launch. So anyway, what's everybody looking forward to? The main thing I'm looking forward to is CST 100 Starliner launch. And I'm not seeing anything. I haven't actually done any serious looking to see what's new with that, but oh goodness. Vega is going to try another launch before too long, and I'm not sure which Vega this is, because Vega's had some serious issues. Upper stage failing to ignite. There's another Falcon Heavy coming up in the future. gotta say, I love the name of Electron's mission names. Like the next one the next one that's coming up, it's another apparently another synthetic aperture radar imaging satellite vehicle, but it says the Moon God Awakens. I'm wondering if it's a lunar mission or what it is. It's apparently coming up later this month, and toward the end of the month, and apparently it's a synthetic aperture radar imaging vehicle. Just don't know if it's going to be around the moon or around the Earth, because they talk about the Moon God Awakens. And what these satellites do, these commercial SIR satellites, what they do is they do imaging of the ground, like for example, to make sure crops are making good enough yields, although a lot of that stuff's done with Landsat. And that's done by, I forget which agency controls Landsat. I believe it to be NASA.
Welcome back.
Oh, here we go.
From Mission Control, we have recycled the count, and we are now less than 13 minutes away from liftoff. Let's listen into the operators as we proceed with the count for our 41st Electron mission.
Okay, standing by for the go-no-go poll. Here we go.
And all stations LD on mission.
T-minus 12 minutes and counting.
Stage.
Stages go for launch.
Avionics.
Avionics is go.
GNC.
GNC is go.
Vcon.
Vcon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM.
MM is go.
And LD SUP.
LD SUP is go.
Okay, that's the go-no-go sequence complete. We are at T-minus 11 minutes and 20 seconds and counting. We're go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
They have just called go for flight. The vehicle is go, as well as the range. T-minus 11 minutes and counting. And as I said, at T-minus 10 minutes, the vehicle will go into terminal count. And at about T-minus 2 minutes, I believe they will transfer from ground-based power to power the batteries aboard the vehicle. And as I'd mentioned before, unlike most rockets, most rocket engines, these use electric-fed pumps. Basically, they use electricity to run the pumps to pump liquid oxygen and RP1 into the engines, as opposed to using something like a gas generator cycle, like Falcon 9 does in an open cycle, and the RD-180 does in a closed oxidizer rich cycle. Standing by, coming up on T-minus 10 minutes.
GC LD mission.
LD GC.
T-minus 10 minutes of counting.
56, pad terminal checks.
And now they're in terminal count. They should also be pulling back the strong back a little bit, like they do with Falcon 9. They'll open up the clamp that's just below the vehicle itself. I mean, just below the area where the kick stage is mated with the second stage, top part of the second stage. And at about T-minus 2 minutes, they will
LDGC on mission.
They will hand full control of the launch sequence from ground-based computers to computers aboard the spacecraft.
Copy, thank you.
Pretty soon they're going to call LOX load complete on both stages.
Avionics LD mission.
LD.
Please proceed with sequence 57 avionics terminal checks.
Proceeding with sequence 57. S-band is switched to high power for flight.
Stage LD mission.
LD stage.
Proceed with sequence 58 stage terminal checks.
Copy that, sequence 58.
Coming up on T-minus 8 minutes. Yeah, the exterior must get absolutely cold.
High voltage batteries ready for flight.
T-minus 8 minutes and counting.
GC LD mission.
LDGC.
Proceed with sequence 59 launch pad ready.
Launch pad ready and work.
And one of the things they'll also do just before engine ignition is they're going to turn on a water deluge to absorb a lot of the acoustic energy that's going to be released upon ignition of the 9 sea-level Rutherford engines.
Avionics LD.
Avionics terminal checks complete.
Copy, thank you.
It's a beautiful evening at Launch Complex 1 as Electron waits on the pad ready for its journey to space. After an earlier hold, we are now on track for a liftoff at 6:55 p.m. local time, making for a stunning nighttime launch. We are fast approaching the launch auto sequence, so let's listen in to mission control for the final critical moments before liftoff.
T-minus 7 minutes and counting.
State LD.
Sequence 58 is complete.
Copy, thank you.
It looks like the clamps are already open and they've pulled back on the strong back in advance of liftoff. It looks like they've also, you can also see the oxygen venting from all the Rutherford engines at the base of the first stage. Making sure it looks like they're doing engine chill, just like they do with Falcon 9, to make sure all the lines as well as the pumps are at operating temperature in advance of ignition. T-minus 6 minutes and counting. And also, one of the things they'll do just immediately prior to launch is pressurize all propellant vessels. Not sure what they use to backfill the emptying spaces as they do that as the propellant tanks drain. I know with Falcon 9 they use liquid helium as a backfill. T-minus 5 minutes and counting.
LDGC on mission.
GC LD.
Hold down mechanisms are armed. The strong back is retracted for flight.
There they go. They just called strong back retract. There it is. In the retracted position in advance of ignition and launch. Just inside of 4.5 minutes. They should be finishing, they should be securing the LO2 and possibly the RP1 lines as well, although RP1 doesn't exactly evaporate, being a liquid at room temperature. T-minus 4 minutes and counting.
GC on mission.
GC LD.
ECS disabled. The pad auto sequence is armed. The pad is ready for launch.
That's always a good thing to hear. At about the T-minus 2 minute mark, auto sequence will hand control from ground-based computers over to the spacecraft's computers, where it will monitor its condition all the way up until the time of ignition and launch, and while maintaining full control of the countdown. In fact, it was something similar to an RSLS, redundant sequence launch set that aborted a launch some weeks back that I covered. T-minus 3 minutes and counting.
Mission. From now on, there should be no red flags in your critical LCCs. VCON LD mission.
LD VCON.
Lock auto sequence and confirm.
Confirmed locked.
And confirm all expected primary flight computer ASGOs are green.
Confirmed ASGOs are green.
Everything sounds nominal thus far.
For auto sequence start at T-minus 2 minutes. LD is
Yep.
go for launch.
Looks like they just ceased topping off of liquid oxygen. They are in the process of venting the lines in the strongback ahead of launch. So auto sequence will start at T-minus 2 minutes, where the control is handed off from the ground to the spacecraft. Standing by. T-minus 2 minutes and counting.
Avionics batteries have switched to internal power.
They have also switched to internal power.
Ground power disabled.
They have now disconnected from ground-based power and are now onboard power.
Is green and enabled for flight.
Everything has handed control over to the vehicle itself ahead of launch. T-minus 90 seconds.
Lock load is complete. System is
There's the call. LOX load has ceased. And we won't see any replenishment going on anymore.
Anti-gathering is disabled.
T-minus 1 minute and counting.
Stage 1 and Stage 2 tanks are pressed.
All propellant tanks are now pressurized ahead of launch. T-minus 30 seconds.
T-minus 20 seconds and counting.
15. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. Ignition and liftoff of Electron, carrying the We Will Never Desert You mission, headed to Earth orbit, and the vehicle has cleared the tower. I don't know if they do any kind of throttle bucketing in this particular flight profile, but coming up at about right around the T+1 minute or so mark, they will be going supersonic, passing Mach 1, and getting ready shortly thereafter to enter the area of maximum aerodynamic pressure, or max Q, which is the denser portions of the lower atmosphere exerting their greatest influence on the vehicle as the vehicle passes through it. There's a view from the first stage, from the second stage.
The rocket experiences the most stress as it climbs. Let's listen in for the call from
We should be passing Mach 1 right about now.
Electron is supersonic.
There's the call. The vehicle has passed Mach 1. And about to enter the area of maximum aerodynamic pressure, or max Q.
High voltage battery discharge is nominal. Cleared max Q.
They just left the area of maximum aerodynamic pressure, and everything should be going a lot less now.
Up to 16 kilometers in altitude as it reaches speeds of more than 2,300 kilometers an hour. Next up are 3 events in Electron's ascent that will happen in quick succession.
First
In about
up,
a
we
minute
have
or so.
Nico, the moment when all 9 Rutherford engines on the first stage throttle down and then shut off completely. Very quickly after that, we'll have the separation of the first and second stages, followed by the ignition of the single Rutherford engine on Electron's second stage as the mission continues to orbit.
Those calls should be coming up from our operators in mission control soon, so let's listen closely.
Here we go. Almost 2 minutes into the flight, and about maybe a little more than half a minute left in the burn.
Approximately 30 seconds.
And as they ascend further and further up, the plume will get bigger and bigger, and the flames are going to start to go away because the oxygen supply for that is starting to dwindle. Coming up on Miko very shortly. Stand by. Throttling down. We have Miko. We should have stage separation. We have stage separation.
Stage separation successful.
And we have ignition of the vacuum-optimized Rutherford engine. Oh. What happened? Upper stage is having a... Something's not right on the second stage.
And all stations, we have experienced an anomaly. Please remain on station, and we will investigate and action the anomaly plan.
Yeah, it looks like they lost power. Yeah, what happened was that when we got telemetry coming down, the speed was starting to drop. I thought it might have been a small glitch, but it looks like it's a fatal anomaly. Something they call, and sometimes they also call, an off-nominal event. And usually whenever they have these events happen, including especially in crewed events, like for example the Columbia, one of the first things they said was lock the doors. Once they had reports of people seeing bits of the spacecraft as it plummeted through the atmosphere, first thing they said was lock the doors and make sure they collect every last piece of evidence, including everything that was said, everything that was written, everything that was read, everything that was heard, everything that was recorded, everything that was played. Basically, what that's done is to that's what they got.
It appears that we've had an issue during today's flight, so we'll be ending today's webcast to give operators time to review the data and share details as soon as they come to hand. Thanks for joining us for today's webcast. This is Mission Control, signing off.
Well, that's unfortunate. I'm going to go back to the chatting window here for just a bit here. I'm going to go to my OBS process here, and I'm going to stop the playback of that because we don't need that anymore. Well, that is very unfortunate that this happens. It does happen, unfortunately. But, yeah, it was, basically what happens is that whenever these things happen, it's, we don't know what happens until they get all the documentation, and maybe they found, like the other one, where they had a failure mode that they didn't encounter before, that they never encountered before. Only this time it's a new one that they haven't encountered before, and will hopefully accommodate for in future launches. So, yeah. I was hoping this wouldn't happen, but unfortunately, those are the breaks in terms of spaceflight. They do happen. So anyway, I guess on that note, I will go ahead and call it a stream. I don't know how to raid with YouTube, and right now, considering the fact that this was an anomalous end to a mission, I don't think I want to. I'd rather do this on one that I know is where a good launch has happened. So in any event, I'd like to say thank you so much for joining me, and as always, Slavu Ukraini, and keep an eye on my socials. I need to actually update that stuff real soon. Thank you so much for joining me, and yeah, sure thing, as always. And until then, I hope you guys have a good enjoy, have a good time. And until then, I will see you then. Have a good one. Bye.